Hello everyone, welcome back to the course on Instrumentation and Process Control. Myself, Nidhi Mehta, Assistant Professor at Chemical Engineering Department, LJIET Institute of Engineering and Technology. Now, let's just start with our topic, which is controllers and final control element. We are quite aware about these two elements of our control system now, as we have seen some basics information about them in our previous session. Now, in this particular session, we will start with the pneumatic controller continuation. Before continuing, we just recall back what we have covered in our last session. In our last session, we have seen mechanism of pneumatic controller and how actually air to close pneumatic controller valve works. In this particular session, we will deal with air to open. As you can see here, air to open control valve, right? We will see how air to open control valve actually works. Now, coming back here, as the name suggests, air to open. If you supply the air into the controller, flow will be start, right? Or the valve opening will be open. The opening between the two chambers of valve can be open if you supply air into the control, right? So, let's just see schematic diagram of this particular control system, as you can see here. In the first instance, it looks exactly similar to air to close valve, right? It is correct to some partial extent, as all the components and everything is same as that of air to close control valve. The only difference remains in the positioning of our plug. If you remember and recall last session, the broader side of our trapezoid was on the upper portion of the stem, whereas in case of air to open valve, the smaller side of trapezoid is connected to the stem, upper side, right? So, let's just recall the mechanism here. Air will be supplied to the air chamber of our motor that is connected to spring and stem. Due to the pressure generated or due to the air pressure generated, the movement will be there, stem will move, right? And as stem will move, it will create opening between the two chambers of our valve. Clear? Now, from the one side, as you can see, air is coming in. From the one side, as you can see here, fluid is coming inside, and this is the opening between two chambers which is being controlled using our plug. Depending on our need, we will supply the air and manipulate the opening between two chambers, which will then allow our liquid to flow into the second chamber, right? Now, this is the proper schematic diagram. As you can see, this is the actual figure of our pneumatic controller, right? In this section, as you can see, air is supplied from this section. Here is the chamber where air is filled, and due to that, pressure is generated, and as pressure is generated, spring will compress, leading to the stem to move downward, and hence our plug will also move downward. Once they move downward, it will generate a space or opening for the fluid to move from this section of our valve to another section of valve which is connected to the pipe. and hence there will be a smooth flowing of liquid between both the section of the valve. So this is the mechanism of air to open valve, where we are simply converting or we are simply inverting the position of plug to get air to open mechanism, right? Next is our controller. We know how pneumatic controller work. Now let's see what and how actually controller works. What is duty of controller and how controller actually works. In this particular figure, it is basically a schematic diagram of control system. As you can see here, in this particular figure, there is a transducer connected to computer or controller, which is again connected to converter, right? And the entire thing is connected to our system. This is basically our system. What we are doing is we are trying to heat the fluid here. Cold process stream is coming from this side. This chamber is a heating chamber or heat exchanger, which will provide heat or heat duty will be carried out in this section of chamber here. It will exchange heat with this cold fluid and try to heat it up to our set point. After that, fluid will come out of the chamber at the next side of this particular chamber. What we are doing and how we are doing, let's see here. We have connected a thermocouple here. As you can see, thermocouple we have connected here. This dot represent a thermocouple. What we have done is, from where our hot stream is coming out of the heat exchanger, we have put thermocouple over there. Signal of thermocouple is sent to the transducer. Transducer, how it is sent? Temperature is converted into current and that is sent to the transducer. Duty of transducer is to convert temperature signal to current signal. See here. We'll see one by one the components. Transducer will temperature to current, right? We are sending the temperature to this transducer. Duty of transducer is to translate the upcoming signal in the form of temperature to the form of current signal. It will translate temperature to current. As you can see, the translated signal is going as 4 to 20 milliampere. That is going into the controller over here. Now in controller what will happen? Controller will try to control it. How it can control? It will control it in the form of signals, right? Now, once you see here, controller will try to control the signal and convert it and send it to converter, where converter will try to take the appropriate action needed. Controller will take the action corresponding to this and that will be taken here, right? So this is the entire flow pattern of control system. Now let's deal with ideal controller. So ideal controller correspond to control valve. So basically a pneumatic control valve always have some dynamic leg, and that is due to stem positioning, right? So how you place your stem determines the action of our controller. So as you can see, control valve for first order system can be related using this particular function, which is control valve first order function Q by P. Output upon input is related as kV upon tau Vs plus 1. Right. Now, kV is basically steady state gain, that is constant of proportionality, and tau v is our time constant of the given valve. Now, coming to the main section here, the time constant of the valve is very small when compared to the time constant of other component. So you can simply ignore that portion and write output upon input as a function of Kv. So, as you know, in today's session we have covered air to open valve or air to open pneumatic controller valve, how it actually works. We have also seen the exact working of our controller, what are different elements which are connected to our controller and how actually our controller works. So basically controller is taking input from the transducer and translate that input into the desired output by removing the error, and that is sent to the final control element which will take the corresponding action, and that corresponding action is being taken by final control element when it is sent to the process, and then process will decide what kind of action has to be taken to overcome this kind of error, right. So this is all about what we have covered in today's session. After that, we also know that how actually air is used to control the valve. By supplying air and by utilizing the pressure of air supplied, we are just dealing or we are just trying to control the entire chemistry or entire working of our valve. In case of air to open valve, when you supply the air, valve will be open and flow of fluid can be take place, and in case of air to close valve, when you supply the air, opening of the valve or opening between two chambers of the valve will be closed and flow of fluid from one chamber to another chamber of the valve will be ceased, and due to that there will be no flow, there will be no fluid which can be flow from that particular valve unless and until we provide a desired opening. Hope all the topics what we have covered today are quite clear. Thank you.